Good day, students. My name is Iwalewa Matthew, still your mathematics teacher. Today we are going to Polygon 2. But before we move to today's class, let us look at or let us remind ourselves of what we have taught in our previous class. In our previous class, we are taught the meaning of polygon, where we said a polygon is a plane shape with different number of sides. And we also look at the types of polygon, where we look at concave polygon, convex polygon, and so on. We also look at the number of sides of a polygon. That is, the number of sides a polygon is being determined by the number of sides. You can only give a polygon its name depending on the number of sides it's having. But today we shall be moving to sum of interior angles of a polygon and the sum of exterior angle of a polygon. Now, sum of interior angles. What do we call interior angles? Interior angles means angles that are present in a circle, in a shape rather. Angles that is being present or angles that are inside a shape. So when we are now talking about the sum of interior angles in a polygon, the sum of interior angles of a polygon is derived from the number of triangles that can be drawn from the polygon. It means the sum of interior angle is gotten through the number of triangles that you can get in a shape. Now let's consider the shapes below, where we have the first shape to be a quadrilateral. When you look at it, you notice that it's a shape that is being enclosed by 4 sides. And when you look at the shape very well, you see that it has 2 triangles. And looking at the next one, we also have a pentagon, which is a shape that is being enclosed by 5 sides. A pentagon. And when you look at the number of triangles that is being derived from it, we have 3 triangles. And the third one that we examine here is the hexagon, which is a plane shape that is being enclosed by 6 lines and is having 4 triangles. So from these 3 diagrams, we can notice that the one that is having 4 sides, which is the quadrilateral, has 2 triangles, and the one that is having 5 sides, which is the pentagon, is having 3 triangles, and the one that is having the 6th side, which is the hexagon, is having 4 triangles. So we can therefore say that n-sided polygon has n minus 2 triangles. It means where n is the number of sides the polygon is having. So when you subtract 2 from the number of sides of the polygon, you get the number of triangles that the shape or the polygon is having. For instance, let's look at a pentagon for an example. A pentagon is a polygon with 10 sides. So if I want to know the number of triangles that are present or that can be derived from a pentagon, which is 10 sides, just subtract 2 from 10, which will give you 8. So it means a pentagon, we have 8 triangles. So when you subtract 2 from it, it will give you 8 triangles. Also nonagon. Nonagon is a polygon with 9 sides. So when you subtract 2 from 9, you have 7. So it means a nonagon will have 7 triangles. So the sum of angles in a triangle is equals to 180 degrees. This one is not new to us, because when you add the sum of angles in a triangle together, it will give you 180 degrees. Also, a polygon with 4 sides having 2 triangles, we have the number of triangles multiplied by the sum of angles in the triangle, which is the number of triangles, which is 2 times 180 degrees, which will give us 360 degrees. Also, if you have 5-sided polygon, it will have 3 triangles. That is 5 minus 2, which will give us 3 triangles, which is the number of triangles, 3, multiplied by the sum of angles in a triangle, which is 180, which will give us 540 degrees. Also, 6-sided polygon, that is 6 minus 2, which will give us 4 triangles. We have 4 times 180 degrees, which will give us 720 degrees. Same thing happens to if I have a shape that is having 10 sides. Are we together? So a shape that is having a 10 side, that is a decagon, which is 10 side. So if I have a shape that is having 10 side, that will be 10 minus 2, which is 8. That will be 8 times 180 degree, and you get your answer. So in general, the sum of the interior angles of any convex n polygon is given by n minus 2 multiplied by 180 degree, where the n is standing for the number of side the triangle or the shape the polygon is having. So the sum of interior angles of any n-sided polygon will be n minus 2 multiplied by 180 degrees. Or sum of interior angles is equals to, open bracket, 2n minus 4 close bracket multiplied by 90 degree, where that 90 degree is a right angle. Don't forget, we can get 2 right angles from a triangle. Now, for a regular polygon that has all its sides and angles equal, that is a regular polygon which has the same size, the same length, and the same angle. The size of each interior angle will be the average of the sum of all interior angles. For instance, in the previous page, we look for the sum of angles in a quadrilateral to be 360 degrees. So if I want to get the sum of each of the angles, I will just divide 360 degrees by 4. And that will give me my answer, which is 90 degrees. So it means each of the angles in a quadrilateral is 90 degrees. So therefore, each interior angle for a regular convex polygon will be, n minus 2 times 180, which is still the same thing as the sum of angles in the polygon, then divided by the number of sides the shape, the polygon, is having. Now let's look at 2 examples here. Example 1. What is the sum of the interior angles of a pentagon? Now, you all know that a pentagon is a polygon with 5 sides. So, for us to look for the interior angles, that will be the formula, which is n minus 2 multiplied by 180 degrees, where n is the number of side, which is 5. That is 5 minus 2, where we have 5 minus 2 multiplied by 180 degrees. And 5 minus 2 will give us 3. So 3 multiplied by 180 degrees, which will give us 540 degrees. So it means the sum of interior angles in a pentagon is 540 degrees. Very simple. Now, example 2. Calculate the size of each interior angle of a regular heptagon. You can see here we are looking for the size of each of the interior angles. So before we can do this, we have to look for the sum of angles in a regular heptagon. An heptagon is a polygon with 7 sides. So we also apply the same formula to get the sum of interior angle, which is n minus 2 multiplied by 180 degrees. Then we divide the result we get there by the number of sides, which is 7. So here we have 7 multiplied by 7 minus 2, which will give us 5. Then multiplied by 180 degrees. Then divided by 7, which is the number of the polygon. The number the polygon is halving, which is 7. So here 5 times 180 degrees will give us 900 degrees. So when you divide 900 degrees by 7, so provide answer to that example 2 yourself. So I've done it for you. So also calculate it, 900 divided by 7, then you get your final answer. So that will give you each interior angle the polygon is having. So let's continue. Then let's move to exterior angles. Don't forget, I told you at the beginning of the class that interior angles means the angles that are being present in a shape, in a plane shape. But exterior angles are now the angles that are outside the shape. So the sum of exterior angle in any polygon is 360 degrees, which means when you want to look for the sum of any exterior angle of any polygon, the sum of angles, the exterior angle of any polygon will give you 360 degrees. So without wasting much of our time, let us look at example 1. The sum of the interior angles of a regular polygon is 10 right angles. You can see here we are given in right angles. Now, how many sides has the polygon? We are now looking for the number of sides. We want to know the shape. So it means here we are not given the number of sides nor the shape. And 2, what is the sum of the exterior angles of the polygon? So after looking for the number of that polygon, then you now look for the sum of the exterior angle. Then after that, you now calculate the size of each exterior angle of the polygon. Now let's go to the solution. The first one, which is the sum of interior angles in that polygon. So here we are given right angles. We are not given the number of sides. Since we are not given the number of sides, so we can use the right angles, which is the second formula that is being given to us when we are dealing with sum of interior angles. So here we have the sum of interior angles when we are given right angle to be, open bracket, 2n minus 4 times 90 degrees, which is right angle. So here, where the right angle is being substituted by the number of the right angle we are given from the question, which is 10. You can see here is the one I underlined, which we have 10 right angles. So here we have 2n minus 4 is equals to 10, which is the number of right angles. So we have here, using balance method here, so we have 2n to be equals to 10. Take minus 4 to the other side. Then the minus will turn to plus 4. So we have 2n is equals to 14. Then for you to know the value of n, divide both sides by the coefficient of n, which is divide both sides by 2. So we have 2n over 2 is equals to 14 over 2, where 2 cancel 2. So 2 cancel 2, we are left with n. Then 2 into 1. Then 2 in 14, we have 7. So it means the polygon we are talking about here is 7-sided polygon. So it's a polygon that is having 7 sides, which is a heptagon. Because I told you that any shape that is being enclosed by 7 sides is called heptagon. So the shape is heptagon. Now let's go to the second one, which is the sum of exterior angles. We all know, I have told us that the sum of exterior angles of any polygon is 360 degrees. So the sum of exterior angle of a heptagon will also be 360 degrees. Even if the polygon is a quadrilateral or a triangle, the sum of the exterior angle will still be 360 degrees. Now, for us to calculate the value of each exterior angle, each exterior angle of that heptagon, that will now be the sum of the exterior angle, which is 360 degrees, then divided by the number of sides. And that is why we cannot get the value of each interior angle if we did not look for the number of sides. So that is the reason why we first look for the name of the polygon, and the number of sides the polygon is having. So with this, you should be able to answer any question on polygons. So don't forget, in summary, what we have learned today, we talk about interior angle, where we are told that the sum of interior angle in any n-sided polygon is open bracket n minus 2 close bracket multiplied by 180 degree. That is if we are given the name of the polygon. But if we are not given the name of the polygon, if you are given the right angle for the polygon, so we use the second formula, which is open bracket 2n minus 4 close bracket times 90 degree, which is representing the right angle. We also learned that the sum of exterior angle of any regular polygon is 360 degrees. And also, if you want to look for each exterior, the value of each exterior angle of any polygon, you first look for the sum of the exterior angle of that polygon, then you divide by the number of sides of that polygon. So with this, if you have any question, you can talk to me on my WhatsApp privately. And please, I'm expecting your question if truly you understand this topic. And please, for this class activity, before you answer your question, make sure you write the question before putting down your answer. And please, when you are sending your answer, make it clear for me to see so that I can be able to mark, assess, and send it back to you. There are some of you that I told you to do the last class activity again, in which I cannot see it clearly. So please, and when you are answering it, please make sure that you write the question first, then you put your solution under it. So, the first question under the class activity for today, we have calculate the size of each exterior angle in a regular octagon. In a regular octagon, you look for the size of each of the exterior angle, which is like the example 2 we did under the sum of exterior angle. And the question 2, is the sum of exterior angle of a triangle equal to the sum of exterior angle of an icosagon? Don't forget, I taught you icosagon in our first class when we are dealing with the number of sides of a polygon. So, and the third question here is, find the measure of one interior angle, one exterior angle, and the interior angle sum for each polygon. You look for the sum of each interior angle of the polygon. Then you can round off your answer to the nearest tenth if probably is necessary for you to do. So you can see the shape is there. You have 3 shapes and you have a space in front of it. So if you cannot draw the shape, just make sure you write the interior angle, write your answer at the front, exterior angle for the number 1, write your answer there, then the sum of the interior angle, also write your answer at the front. So use that as your question 3. So you can use it as 3 Roman figure 1, 3 Roman figure 2, and 3 Roman figure 3. So I wish you best of luck. We meet on Saturday for our normal assessment. Good day. Thank you.